starting out with Pythagorean Theorem. Pythagorean Theorem works only on right triangles. So if you have a right triangle, these are your legs. So this would be your A and B. They are adjacent to the 90-degree angle. And then your hypotenuse is C. And the equation for Pythagorean Theorem is a squared plus b squared equals c squared. Okay, so then using that for number 1, this would be your A and B, and then this is your C, your hypotenuse. So you'd set it up like this: 13 squared plus 23 squared equals x squared. And some people ask, like, how do you tell what's A and B? It's interchangeable. The legs are just A and B. Okay, and then from here you'd start plugging stuff in your calculator. 13 squared comes out to 169. 23 squared is 529. You'd add these two values together, come out to 698 equals x squared. And then the last step is to take the square root of each side to get rid of the x squared, and then take the square root of this, and x comes out to 26.4. On the test, everything is multiple choice. I just took out the multiple choice to give us more room to solve on here. Okay, for the next problem, we have our two legs right here, so this would be A and B. And C, for this one of our A and B is a variable. So it's set up like this: x squared plus 21 squared equals 34 squared. And so you get x squared, 21 squared is 441, and 34 squared is 1,156. Then you're trying to get x by itself, so we subtract 441 from both sides. 715. And then the last step is to take square root, and x equals 26.7. Okay, number 3 shows an isosceles triangle with an altitude. This altitude makes a right triangle over here, and since it's isosceles, this would be like the midpoint here. So this is 9, half of 18, which would be 9. And then you have your A and B and C. So it'd be x squared plus 9 squared equals 26 squared. 26 squared is 676. Subtract 81. Square root both sides, and x equals 24.4. Okay, for the next set of problems, it says determine whether each set of numbers can be measures of the sides of a triangle. If so, classify as acute, obtuse, or right, and justify your answer. Okay, so for an acute triangle, a squared plus b squared would be greater than c squared. And for obtuse, a squared plus b squared would be less than c squared. And then for a right triangle, it would be equal. A squared plus b squared is equal to c squared. So we're going to take these numbers and just figure out what works, equals, or whatnot. So we got 10 squared plus 11 squared, and we compare that to 20 squared. So we got 100 plus 121. 20 squared would be 400. And so 100 plus 121 would be like 221, so definitely less than. So that means this would be obtuse. Then for the next one, 5 squared to 2 squared plus 10 squared compared to 11 squared. So 121, 100 plus. There's different ways you could solve this. One way would be plug it into a calculator. Let's see, you could do square root of 2 times 5 and then square that number. And it comes out to 50. So this comes out to 50. 50 plus 100, 150 is greater than 121. So we have a cube. Then number 6, 65 squared plus 72 squared. Compare it to 97 squared. This is 4,225. 5184. And 97 squared is 9409. Then when you add these two together, it comes out to 9409, which is equal to 9409. So this would be a right triangle. Okay, next one. Okay, so then we have special right triangles as this whole column. There was two special right triangles. One is the 45, 45, 90. So for a 45, 45, 90 degree triangle, it's of course a right triangle, 45, 45, 90. It's isosceles, so these two legs are the same length, so this would be x and x. And then the hypotenuse is the side length times square root of 2. Okay, and then using these ratios, we'll solve for side length here. So it gives us a leg, and then to find the hypotenuse, we need to multiply by square root of 2. So this would be 14 square root of 2. Then for number 8, again, side length to the hypotenuse times square root of 2, so 22 square root of 2. And number 9, side length to the hypotenuse times square root of 2, 88 square root of 2. Okay, next one, it says find x and y. This is the other version of the special right triangle. So this would be the 30, 60, 90 one. So for the 30, 60, 90, you have a 30-degree angle, a 60-degree angle. The shortest side is opposite the 30-degree angle, so this is your shortest side. We'll call that S. The hypotenuse is 2 times your shortest side, and then the medium length side is your shortest side times square root of 3. That's 2S. Yes. Okay, so here it gives us our shortest side. The hypotenuse is 2 times the shortest side. I'm trying to make that look like an S as much as I can. And then this is shortest side times square root of 3. So to get this here, times 2 would be 18. And then here, times square root of 3 would be 9 square root of 3. And then for 11, remember this is the shortest side, 2 times the shortest side, and then shortest side times square root of 3. So times 2 would be 40, and times square root of 3, 20 square root of 3. Okay, next. Okay, so that is special right triangles, and then the last column is trigonometry. This is the one that we spent the most time on just because it comes up a lot in Algebra 2, Pre-Calc, and Calculus. So SOHCAHTOA is the acronym we used to remember like the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So first thing we need to do is determine which one of these we're going to use to solve this. So you identify the angle that they labeled. And then from that angle, we have opposite and adjacent. So you use that to figure out which one of these to use. So we're going to use tangent. Tan of 64 is x over 11. Then to solve from here, multiply. We're trying to get x by itself, so we multiply both sides by 11. We get 11 tan 64 equals x. Realize a lot of you might not have calculators, that's okay. So the way you would plug this in is 64 tan times 11, and you get the answer. So this would be 22.6. Okay. 13, continuing that same process, for designated angle. From there we have adjacent and hypotenuse. So based on SOHCAHTOA with A and H, we want to use cosine this time. Multiply this by 32, this by 32, 32 cosine 41 equals x. Then you do 41 cosine times 32, 24.2. Adjacent and hypotenuse. That would be adjacent to the 41 degrees. Opposite would be right here. Opposite this angle. Okay, the next two, we're finding the degree of the angle. It says use a calculator to find the measure of angle B. So angle B is now our designated angle. We're going to use SOHCAHTOA again. Then from this angle, we have hypotenuse and adjacent. Opposite would be here, but it's not labeled. And then A and H, we're going to use cosine of B is 25 over 30. Adjacent over hypotenuse. Then to solve this, you would do 25 divided by 30 equals, get the decimal, and then second cosine. So remember to do second, maybe make a note, second cosine. B degrees is 33.6. $15 from this angle adjacent and hypotenuse. This one can be kind of hard to tell if that's the hypotenuse. Hypotenuse is your longest side. It's always opposite the 90-degree angle, so that's why that's your hypotenuse. Then with A and H, again, happens to be cosine. And in the calculator, 7 divided by 30, well, 7 divided by 39 equals, and then second cosine comes out to 79.7. And the last one, angle here, opposite hypotenuse. So with OH, we're going to use sine. 67 degrees is opposite over hypotenuse. Multiply this by 20 and this by 20. 20 sine 67 equals x. And 18.4. And that's all. Okay, so at this point, I'm going to have you just leave this out on your desk so I can come around and give you credit for it. We don't have the laptops today. I do want you to start your Alex for the week just because we have a pretty busy week. So yeah, you can take your phones, do a couple Alexes while you're thinking about it, and leave your work out. Yeah, just sign out. When is about this? Oh, sorry, I'm in. Next time, jump in front.